Hello and welcome back to my channel. Today we are going to continue with the last few questions of Cambridge AS and A level pure mathematics 3 solution from May-June 2021 9709, and the component is 33. We have already discussed the first 5 questions of this paper, so let's start with the question number 6. Here's the question number 6a part. By sketching a suitable pair of graphs, show that the equation cot half x equals 1 plus e to the power minus x has exactly one root in the interval 0 to pi. So here we have two graphs. We need to sketch the graph. Generally we take left hand side as one graph and the right hand side as another graph. So here we have left hand side as y equals cot half x, and the right hand side graph become 1 plus e to the power minus x, and in the y equals cot x by 2 the period is going to be 2 pi, and this is exponential graph. So this is going to be like this, of this shape, which is going to pass through x equals pi, and 1 plus e to the power minus x graph will look like this, and it is going to be a translation, horizontal vertical translation by 1. So I have used the technology to show the graph where we can see it is going to meet at one place. So here is the graph. This is the graph of y. Red curve is going to be the graph of y equals cot x by 2, and y equals 1 plus e to the power minus x is this graph, yellow, and we can see between 0 and pi it is meeting at single point, only one point. That's why it has only one root, exactly one root in the interval 0 to pi. So basically when we in these type of question we sketch the graph, and we can show that it is meeting only at one point. It is not compulsory to get exact graph, it is just approximate graph. The only thing is the properties which we know it should follow. For example, e to the power 1 plus e to the power minus x has to get a horizontal asymptote as y equals 1. We can see it is the y equals 1, and cot x graph has to be like that, and it has to pass through pi on x axis. So because it is cot x by 2, so its period is 2 pi. I hope it is clear. Let's discuss the second part of it. So B part, verify by calculation that this root lies between 1 and 1.5. So we will write the equation again. The equation was cot half x equals 1 plus e to the power minus x. In these type of cases we'll make a function. We can make a function fx as either we can take all the right hand side terms to the left hand side, or otherwise we can take left hand side terms to the right hand side to make a function. So in this case I'm going to write the function as cot half x minus 1 minus e to the power minus x. Now we are going to use the property that if we have these if we have f of 1 and f of 1.5 as a different sign, these values are of different sign, doesn't matter which one is negative, which one is positive. If we have the different sign, so we can say directly that root lies between these two values. So we will substitute this value in the calculator, and we will directly get the value of f of 1 and f of 1.5. Cot x by 2, it's not there in the calculator directly, so we can write this thing again as 1 upon tan half x, and rest of the things would be as such. One is going to be 0.4626 and so on. this is minus 0.1497 and so on. So we can see they have it is greater than 0, f of 1 is greater than 0 and f of 1.5 is less than 0, hence root lies between 1 and 1.5. I hope it is clear. Let's discuss the next question. C part. Use the iterative formula xn plus 1 equals 2 tan inverse 1 over 1 plus e to the power minus xn to determine the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. So we have this iterative formula. In this we'll get a starting point. From the B part we have seen the root is lying between 1 and 1.5, so we can choose any value in between. So let's take x. I will not take x naught. Let's say first iteration we are going to take from our side x1, any value between 1 and 1.5. I'll take 1.25. We can take any value. So x1 become 1.25. So I will substitute to this 1.25. I'll give this value or feed this value in the calculator display, so that I only have to use x2 only once as 2 tan inverse 1 upon 1 plus e to the power minus x1 just once, and we will get the answer. And this value is going to be 2 into tangent inverse of 1 over 1 plus, and in the place of xn, that is x1, I will directly use answer. So it is minus answer, and the value is 1 point. Since they have asked us to write the iteration to 4 decimal places, so I'll write 1.3214 and so on. And now x3 value we will directly get just by getting the equal key, and the next value I'm getting next iteration is 1.3365 and so on. x4 again I will press equal key. I'm getting 1.3395 and so on. Again fifth iteration is x5 is 1.3402 and so on. x6 is 1.3403. we will check till that we get correct root till 3 decimal places. So we can judge from here itself that till 3 decimal places we are getting 00340. So we can give or approximate or the root means x value, the solution of it as 1.34, because they have asked us to write the root correct to 2 decimal places, so we can say it is 1.34. Rest can be different, but we can check by getting the next iterative value. x7 is coming 1.343 again, so it is 1.34 correct to 2 decimal places. Now in the 7th question we can see there is a curve. So for the curve shown in the diagram, the normal to the curve at the point P, the normal to the curve means this is the normal with the coordinates x, y, meets the x-axis at n. We can see it's meeting here. The point M is the foot of perpendicular from P to the x-axis, so it is 90 degree. The curve is such that for all values of x in the interval 0 to half pi, that is pi by 2, the area of the triangle PMN is equal to tan x. So first part is we need to show that mn over y equals dy over dx, and it is of 1 mark. So we have to just think like definition wise, what is the definition of it, or we can say what is it, we will check the knowledge behind it. So we know that this Pn Pn is the normal, and dy over dx for any curve is the gradient of the tangent. So gradient of normal or perpendicular line is going to be negative reciprocal of the gradient of the tangent. So it means the gradient of Pn is going to be minus 1 over dy over dx. And from the diagram we can see, the diagram shows this, and from the diagram, from the definition, we know the gradient of Pn is minus 1 over dy over dx, and from the diagram we have gradient of Pn as rise upon run I will use, and it is going to be minus Pm upon Mn. And we know it's given that P has the coordinates as x comma y. It means Pm is y, so it become minus y over Mn. And now we will cross multiply, and we will get Mn over y equals dy over dx, and that carries only 1 mark, because we have just used the knowledge of normal equation or gradient of the normal and what is the relation between the gradient of the curve. And in the B part, hence show that x and y satisfy the differential equation this. So we have seen from the condition of the first question, for condition of the question, it has in the interval 0 to pi by 2, the area of the triangle PMN is equal to tan x, and area of the triangle here we see, if we see area of this triangle, we know that this is y and this is the base, Mn. So area of this triangle is going to be half base into height, and this is given as tan x. This is from the question. And from the first part we have seen Mn upon y equals dy over dx. So what we will do, we are going to transfer this, I will substitute the value of Mn from the first part into this, and then we will get Mn half, I will write here half Mn into y equals tan x. And from the first part we have seen it was Mn upon y equals dy over dx. So I am going to get Mn from the first part. Mn is y times dy over dx. I will substitute here. I will get half y into y square, and dy over dx as tan x, and that's the same differential equation we require. Now in the B part, given that y equals 1 when x equals 0, solve this differential equation to find the equation of the curve expressing y in terms of x. So we can see the differential equation was 1 upon 2 y square dy over dx as tan x. And in A level we have only one method, that is the variable separable method. So I will simply take y terms one side and x terms one side so that we can integrate it. So this can be written as half y square dy equals tan x dx, and then we will integrate both the side. Left hand side integration is easy because it's just y square. We will separately solve the integration of right hand side, that is integration of tan x. So as such we don't have the formula for it, so we will use tan x as sin x upon cos x dx. And now we are going to take this, we can think of it as minus or you can say f dash x upon fx dx is ln modulus fx. because we know that cos x differentiation is going to be minus sin x, so we can write this as minus here and minus here, so that we can get the numerator as f dash x. Now it means the integration become 1 upon 2 into y square, integration become y, it is going to be y cube upon 3, and here it is going to be minus ln cos x, we can write in the modulus also, and plus c. So now we will substitute the values, initial values. We have y equals 1 when x was 0, so left hand side become only 1 by 6, and right hand side we know cos 1, we know cos x is 0, so cos x is 1, cos 0 is 1, and ln 1 is 0, so ultimately we get minus 0 here plus c, or we can say c value as 1 by 6. So we got this thing as 1 by 6 y cube equals minus ln cos x plus 1 by 6. Now I'll transfer 6 to the other side, and we are left with y cube equals minus 6 ln cos x plus 1, because 6 got cancelled, and ultimately we got our answer y as cube root of minus 6 ln cos x and plus 1, and this is the y in terms of x. I hope it is clear. Let's discuss the next question now. Question number 8. The diagram shows the curve y equals ln x over x power 4 and its maximum point m. A part is find the exact coordinates of m. Since it is a maximum point, so it means we are going to find the derivative of it, and the derivative has to be 0 at m. So let's find the derivative of it. It is the quotient function, so derivative would be the quotient rule. Dy over dx is denominator square, so x power 4 to the power 2 is x to the power 8, and denominator as such, that is x to the power 4, into the differentiation of numerator, that is differentiation of ln x, it is 1 by x, minus numerator as such and derivative of denominator. X power 4 denominator is the denominator, so its differentiation is 4x cube, and we can simplify this and we'll get x cube minus 4x cube ln x over x to the power 8. We can take x cube common and we can cancel, so directly we can write it as 1 minus 4 ln x upon 3 power got cancelled, so x to the power 5. And for the at m means maximum point, our dy derivative has to be 0. It means 1 minus 4 ln x upon x to the power 5 has to be 0. In order to get a quotient as 0, numerator has to be 0. It means 1 minus 4 ln x equals 0, or 1 equals 4 ln x. So 1 by 4 equals ln x, or we can say x is e to the power 1 by 4. And that's the exact coordinate, x coordinate of m. And for y coordinate, we are just going to substitute this x value here. So y is, this means y is ln e to the power 1 by 4 over e to the power 1 by 4 whole to the power 4, and we can use this property, ln a to the power b is b into ln a, means 1 by 4, I will write in the same numerator denominator form, into ln e over a to the power m to the power n, so mn, it means e, and ln e is 1, so ultimately we got this thing as 1 over 4e, and hence the exact coordinates of m is e to the power 1 by 4 comma 1 over 4e. Now in the B part of the same question, by using integration by parts, show that for all a greater than 1, the integration from 1 to a ln x over x to the power 4 dx is less than 1 by 9. So in this case we are going to integrate first of all. So integration by part is, we are going to take this as we will divide into two parts here. So first part we can say u, and another part is dv over dx, so that we can use the formula for it. So first function we have to take ln x. Anyway, if we forgot that there is no there is such method, we can simply think of ln x. We don't know the integration of ln x directly, so we are going to use the we will take the first function ln x as first function, and remaining, that is the second function, as 1 upon x to the power 4 as dv over dx, or we can say x to the power minus 4. And here we will calculate du over dx, which is 1 over x, and from here we will integrate to get v value, and v value means integration of this, it is x to the power minus 3 over minus 3, or minus 1 over 3x cube. So now we will use this integration by part formula, and this integration, I will mark this thing as I. So this I become uv, it means minus 1 upon 3 x cube ln x minus integration of du over dx, that is 1 upon x, into v. V is minus 1 upon 3, so minus 1 upon 3 x cube, and then dx. We can simplify it again, it is minus 1 over 3 x cube ln x, minus minus plus, and then it become 1 upon 3, also I will take it outside of this, and x to the power minus 4 dx. So we need to integrate it again. So our integration I become, and sorry, not this, 1 minus 1 over 3 x cube ln x minus 1 upon 3, because x to the power minus 4, the integration of this is going to be minus 1 upon 3 x to the power minus 3. So I wrote minus 3 here, or we can simply write this thing as minus 1 over 3 x cube ln x minus 1 over 9 x to the power 3. Now since it is the definite integral, so we will put this limit 1 to a. So upper limit, this become minus 1 over 3 a cube ln a minus 1 over 9 a cube, minus the lower limit, so minus again minus, so it become plus 1 upon 3 x cube become 1 ln 1, and we know it is 0, and again minus minus plus 1 upon 9, 1 cube is 1 upon 9, which we can write as 1 upon 9, I am writing it as a first term, minus 1 upon 3 a cube ln a minus 1 upon 9 a cube. So we can see that a, it was given that a is greater than 1. A is greater than 1 means ln a is greater than 0, and 1 upon 9 a cube is also greater than 0. 1 upon 3 a cube is also greater than 0. It means the whole I is going to be 1 upon 9 and something greater than 0, or we can say minus something greater than 0. So we can directly say that our integration I, which was actually 1 to a ln x upon x to the power 4 dx, it is going to be less than 1 by 9, because we are subtracting a positive quantity from 1 by 9, so it will be always less than 1 by 9, and that's what we had to prove. Here's the question number 9. The quadrilateral ABCD is a trapezium in which AB and DC are parallel with respect to the origin O. The position vectors of A, B and C are given by OA as minus I plus 2j plus 3k, and OB as I plus 3j plus k, and OC as 2I 2j minus 3k. A part is given that DC vector is given as 3 times AB vector. Find the position vector of D. So, position vector of D means OD vector. So, ultimately we need to find OD vector. Now, it's our wish how can we go from O to D, and obviously we will find a path which is known. So, we can directly go from O to C, and then we can go from C to D, because we have O to C, OC vector we have, and CD vector, though we don't have CD vector, but we have DC vector as 3 times AB vector, and since we have position vector of A and position vector of B, we can find AB vector easily. So we can rewrite this thing as OC vector minus DC vector, because we know that AB vector is minus times BA vector, and this we can write from the condition as OC vector minus 3 times AB vector. And now we will find AB vector. OC vector is given. OC vector is 2I cap plus 2j cap minus 3k cap, and minus 3 times AB vector. AB vector means OB minus OA, or we can say position vector of B minus position vector of A. So I minus I, it become 2I cap, 3j minus 2j is plus j cap, and k minus 3k is minus 2k cap. That's the AB vector. So we can simplify it. It is going to be 2I cap plus 2j cap minus 3k cap minus 6I cap minus 3j cap plus 6k cap. So collecting them together we get minus 4I cap and minus j cap plus 3k cap. So that's the position vector of D, or we can say OD vector. In the second part, state a vector equation for the line through A and B. So we know the position vector of or we can say equation of a line is always going to be R equals a point on the line plus lambda times, or let's say T times a parallel vector. Since it is passing through A and B, we can take A as the point on the line and AB as the direction vector. So from the first part we will copy what is A. OA is minus 2 3 minus 1 2 3. So I'll write OA here, OA as minus plus 2 plus 3, and since it is passing through AB, so we require AB. AB is 2 1 minus 2 we have calculated. So AB vector as 2 1 minus 2. Let's check again. Yeah, 2 I cap plus j cap minus 2k cap, 2 I cap plus j cap minus 2k cap. So since we have the position vector on the a point on the line and the direction vector, so the vector equation of the line through A and B is R equals minus I cap plus 2 j cap plus 3 k cap plus lambda times, or we can say T times, here we have written T, so T times 2 I cap plus j cap minus 2 k cap. So that's the vector equation of the line through A and B. Now in the C part, find the distance between the parallel sides and hence find the area of the trapezium. So if we can, I will draw to visualize this. We have, let's say, A, B, and these are the two parallel sides. Let's say A, B, C, and D. And it's given that AB and DC are parallel. So, and we found the vector equation of the line passing through AB. So here's the vector equation of the line passing through AB. So if we can think about a point on the line, this line, let's say this point, this is a point such that this is perpendicular to DC, or we can say if we take it as P, so PD is perpendicular to the line AB or vector AB. So in this way we can find the, once we get P value, or we can say find the PD distance, magnitude of it. So we have the distance, and then we will find DC vector, AB vector, so that we can calculate the area of the trapezium. So any point P, for any point P, the position vector of P is going to be OP vector. We can take it as, I'll write it as a column vector. It looks it is easier to calculate in that way. So it is -1 plus 2t, any general point P. So it is -1 plus 2t, 2 plus t, and 3 minus 2t. That's the OP vector. And we had AB vector. We know that OP vector, once we have OP vector, and D, position vector of D, we have from the first part, and it was -4 -1 plus 3, -4 -1 and 3. So we can calculate PD vector now. PD vector is D minus P. So -4 -1 minus 2t is going to be minus plus. So it is -3 plus -3 minus 2t. 2 minus -1 minus 2 is going to be -3 and minus t, and 3 minus 3 is 0, so it is only 2t. Now the angle between AB and PD is 0, so it means PD dot AB has to be 0, means we have -3 minus 2t minus 3 minus t and 2t dot product with AB. AB is 2 1 minus 2, this has to be 0, or we can say it is -6 minus 4t minus 3 minus t minus 4t equals 0. So it is -6 minus 3 minus 9, and -4 minus 1 minus 4, again this is also -9t equals 0, or we can say t value as -1. So once we got t value as -1, so it means we got exact coordinate of P such that this is 90 degree. So we got PD vector as, we will substitute t equals -1. So it is -3 plus 2 is -1, -3 minus minus, so -3 plus 1 is -2, and 2 minus 1 is -2. So that's the PD. So its length would be magnitude of it, which is square root of 1 plus 4 plus 4, it is 3, and AB, magnitude of AB vector, it is going to be AB was 2 1 minus 2, that is again 4 plus 1 plus 4, it is again 3. And from the first question we have seen that DC is 3 times of AB. It means the DC length, or we can say magnitude of DC, is going to be 3 times of 3, that is 9. So the area of trapezium, is half into the sum of the parallel sides, that is 3 plus 9, into its height, distance between the parallel side, that is 3 again. So 9 plus 3 12 upon 2 6 into 3 18. So it is 18 unit square. That's the area of the trapezium. I hope it is clear. And here's the question number 10, which is the last question of this paper. Verify that minus 1 plus 2 root 2 iota is a root of the equation z power 4 plus 3z square plus 2z plus 12 equals 0. So in order to verify this, it means if we substitute the z value as this, we need to get the left hand side equals right hand side. So the best way is we can first of all find the required things to substitute. For example, z is there, which is here. We'll find z square separately, and then we'll find z power 4, so that we can just plug in the values at the last. So here the z, if we take z as, I'll take z as this, minus 1 plus root 2 iota, or we can rewrite this thing as root 2 iota minus 1, both are same. And then z square is going to be the square of root 2 iota minus 1, which is root 2 iota square is 2 iota square, and iota square is minus 1, so it is minus 2 plus 1 square, so it is 1 minus 2 times of a into b, it is a minus b whole square identity, so it is going to be 2 root 2 iota, or we can say it is minus 1 minus 2 root 2 iota. That's the z square. And now from here we can calculate z power 4. So z power 4 means the square of z square, and that means minus 1 minus 2 root 2 iota square, which is going to be 1 square, so 1, and 2 root 2 square iota square, so iota square will make it minus 2 root 2 square is 4 into 2 8, and again plus, because minus it is simply a plus b, it is going to be 2 into 2 4 root 2 iota. So if we have we can simplify it, not that it's not a big deal, we can do it in any way. So it is going to be minus 7 plus 4 root 2 iota. So we are going to plug in these values here. So left hand side is z power 4 means minus 7 plus 4 root 2 iota plus 3 times z square, so it is going to be minus 3 minus 6 root 2 iota, and plus 2 times z, that is 2 root 2 iota minus 2 plus 12. So it is minus 7 minus 3 minus 2 plus 12, and 4 root 2 iota minus 6 root 2 iota and plus 2 root 2 iota. Minus 7 minus 3 minus 2 is minus 12, so minus 12 plus 12, and 4 minus 6 is minus 2 plus 2 root iota, so it is 0 times iota, or we can say this is also got cancelled and we are left with 0, which is actually the right hand side. Hence minus 1 plus root 2 iota is a root. This is just one root of the equation. Now in the b part we need to find the other roots of this equation. So from the first part we have seen it is minus 1 plus root 2 iota as the one root. It means we know the coefficient of this polynomial or equation are real numbers, so the another root has to be minus 1 minus root 2 iota. So once we got two roots, so we will make a polynomial so that we can think of other roots of z power 4 plus 3 z square plus 2z plus 12 equals 0. Let's check if it was the same. 3z square plus 2z plus 12, yes. So now if we have these two as the root, then it means z minus -1 plus root 2 iota and z minus -1 minus root 2 iota are the factors of this polynomial if we take only the polynomial, means left hand side. So we will simplify, we will take a product of it. It is going to be again z minus plus minus root 2 iota, and here it is z plus 1 plus root 2 iota. In this we have to be careful because this is going to be simply a plus b, a minus b. This is a, this is b, this is a, this is b. So it is z plus 1. I am using this small z so that we will not confuse between z and 2, and minus root 2 iota square. So it is z square plus 2z plus 1, and minus iota square means again minus 1, so it is plus, and root 2 square is 2. So we got z power 2 plus 2z plus 3, and this is a factor of this polynomial. So it means if we divide this polynomial, we will get remainder as 0. So let's divide. Z power 4 plus 3z square plus 2z plus 12 dividing by z square plus 2z plus 3. So first term is going to be z power 2, and then we will multiply, we will get z power 4 plus 2z cube plus 3z square. We will change the sign, minus minus minus, these two got cancelled, and this is minus 2z cube minus 3z square plus 3z square got cancelled, and we are left with plus 2z plus 12. Now we will choose minus 2z. We can get this quotient just by dividing the leading term from the divisor and dividend. So minus 2z, if we multiply, we will get minus 2z cube, and then minus 4z square minus 6z, and then again sign change, plus plus plus, these two got cancelled, and this is 4z square plus 6 plus 2 8z plus 12. And now we will choose 4. So it is 4z square, 4 into 2 8z plus 4 into 3 12, sign change, and this got cancelled and we got remainder as 0. It means we got the quotient. So for the other roots we will find the 0 of this polynomial, means z to the power 2 minus 2z plus 4 equals 0, and for the roots z is going to be, by the quadratic formula, it is minus b, so it is 2 plus minus root b square, that is 4, minus 4ac, that is minus 16, over 2a, that is 2. It means it is 2 plus minus minus 12 upon 2, and it is 2 plus minus 4, so 4 into 3, that is 2 will come out, and this is minus 3, and this 2 we can write again this thing as will divide by 2 everywhere. We are left with 1 plus minus root 3 and iota, because minus root iota, root minus iota, root minus 1 is iota. So we got all the roots. So 4 roots are minus 1 plus root 2 iota, minus 1 minus root 2 iota, and 1 plus root 3 iota, and 1 minus root 3 iota. These are the 4 roots. So this was the last question and the last part of this paper. So let's meet again in the solution of the another paper. Till then, thank you so much.